Overfishing is a form of overexploitation where fish stocks are reduced to below acceptable levels. Overfishing can occur in water bodies of any sizes, such as ponds, rivers, lakes or oceans, and can result in resource depletion, reduced biological growth rates and low biomass levels. Sustained overfishing can lead to critical depensation, where the fish population is no longer able to sustain itself. Some forms of overfishing, for example the overfishing of sharks, has led to the upset of entire marine ecosystems. The ability of a fishery to recover from overfishing depends on whether the ecosystem's conditions are suitable for the recovery. Dramatic changes in species composition can result in an ecosystem shift, where other equilibrium energy flows involve species compositions different from those that had been present before the depletion of the original fish stock. For example, once trout have been overfished, carp might take over in a way that makes it impossible for the trout to re-establish a breeding population. Overfishing occurs when more fish are caught than the population can replace through natural reproduction. Gathering as many fish as possible may seem like a profitable practice, but overfishing has serious consequences. The results not only affect the balance of life in the oceans, but also the social and economic well-being of the coastal communities who depend on fish for the way of life. Global overfishing. Overfishing has significantly affected many fisheries around the world. As much as 85% of the world's fisheries may be overexploited, depleted, fully exploited, or in recovery from exploitation. Significant overfishing has been observed in pre-industrial times. In particular, the overfishing of the western Atlantic Ocean from the earliest days of European colonization of the Americas has been well documented. Following World War II, industrial fishing rapidly expanded with rapid increases in worldwide fishing catches. However, many fisheries have either collapsed or degraded to a point where increased catches are no longer possible. Daniel Pauly, a fisheries scientist known for pioneering work on the human impacts on global fisheries, has commented, "It is almost as though we use our military to fight the animals in the ocean. We are gradually winning this war to exterminate them, and to see this destruction happen for nothing really, for no reason, that is a bit frustrating." Strangely enough, these effects are all reversible. All the animals that have disappeared would reappear, all the animals that were small would grow, all the relationships that you can't see anymore would re-establish themselves, and the system would re-emerge. Examples of overfishing. Examples of overfishing exist in areas such as the North Sea, the Grand Banks of Newfoundland and the East China Sea. In these locations, overfishing has not only proved disastrous to fish stocks but also to the fishing communities relying on the harvest. Like other extractive industries such as forestry and hunting, fisheries are susceptible to economic interaction between ownership, stewardship and sustainability, otherwise known as the tragedy of the commons. The Peruvian coastal anchovy fisheries crashed in the 1970s after overfishing and an El Niño season largely depleted anchovies from its waters. Anchovies were a major natural resource in Peru. Indeed, 1971 alone yielded 10.2 million metric tons of anchovies. However, the following 5 years saw the Peruvian fleet's catch amount to only about 4 million tons. This was a major loss to Peru's economy. The collapse of the cod fishery off Newfoundland, and the 1992 decision by Canada to impose an indefinite moratorium on the Grand Banks, is a dramatic example of the consequences of overfishing. The sole fisheries in the Irish Sea, the West English Channel, and other locations have become overfished to the point of virtual collapse, according to the UK government's official Biodiversity Action Plan. The United Kingdom has created elements within this plan to attempt to restore this fishery, but the expanding global human population and the expanding demand for fish has reached a point where demand for food threatens the stability of these fisheries, if not the species' survival. Many deep-sea fish are at risk, such as orange roughy, Patagonian toothfish, and sablefish. The deep sea is almost completely dark, near freezing, and has little food. Deep-sea fish grow slowly because of limited food, have slow metabolisms, low reproductive rates, and many don't reach breeding maturity for 30 to 40 years. A fillet of orange roughy at the store is probably at least 50 years old. Most deep-sea fish are in international waters, where there are no legal protections. Most of these fish are caught by deep trawlers near seamounts, where they congregate because of food. Flash freezing allows the trawlers to work for days at a time, and modern fish finders target the fish with ease. Blue walleye became extinct in the Great Lakes in the 1980s. Until the middle of the 20th century, it was a commercially valuable fish, with about 500,000 tons being landed during the period from about 1880 to the late 1950s, when the populations collapsed, apparently through a combination of overfishing, anthropogenic eutrophication, and competition with the introduced rainbow smelt. The World Wildlife Fund and the Zoological Society of London jointly issued their Living Blue Planet report on the 16th of September 2015, which states that there was a dramatic fall of 74% in worldwide stocks of the important scombroidii fish such as mackerel, tuna and bonitos between 1970 and 2010, and the global overall population sizes of mammals, birds, reptiles, amphibians and fish fell by half on average in just 40 years. Examples of good fisheries management. Several countries are now effectively managing the fisheries. Examples include Iceland and New Zealand. The United States has turned many of its fisheries around from being in a highly depleted state. Consequences. According to a 2008 UN report, the world's fishing fleets are losing $50 billion each year through depleted stocks and poor fisheries management. The report is produced jointly by the World Bank and the UN Food and Agriculture Organization. Asserts that half the world's fishing fleet could be scrapped with no change in catch. In addition, the biomass of global fish stocks have been allowed to run down to the point where it is no longer possible to catch the amount of fish that could be caught. Increased incidence of schistosomiasis in Africa has been linked to declines of fish species that eat the snails carrying the disease-causing parasites. Massive growth of jellyfish populations threaten fish stocks, as they compete with fish for food, eat fish eggs, and poison a swarm fish, and can survive in oxygen-depleted environments where fish cannot. They wreak massive havoc on commercial fisheries. Overfishing eliminates a major jellyfish competitor and predator, exacerbating the jellyfish population explosion. Types. There are three recognized types of biological overfishing: growth overfishing, recruit overfishing, and ecosystem overfishing. Growth overfishing. Growth overfishing occurs when fish are harvested at an average size that is smaller than the size that would produce the maximum yield per recruit. A recruit is an individual that makes it to maturity, or into the limits specified by a fishery, which are usually size or age. This makes the total yield less than it would be if the fish were allowed to grow to an appropriate size. It can be countered by reducing fishing mortality to lower levels and increasing the average size of harvested fish to a size that will allow maximum yield per recruit. Recruitment overfishing. Recruitment overfishing occurs when the mature adult population is depleted to a level where it no longer has the reproductive capacity to replenish itself. There are not enough adults to produce offspring. Increasing the spawning stock biomass to a target level is the approach taken by managers to restore an overfished population to sustainable levels. This is generally accomplished by placing moratoriums, quotas and minimum size limits on a fish population. Ecosystem overfishing. Ecosystem overfishing occurs when the balance of the ecosystem is altered by overfishing, with declines in the abundance of large predatory species. The abundance of small forage type increases, causing a shift in the balance of the ecosystem towards smaller fish species. Acceptable levels. The notion of overfishing hinges on what is meant by an acceptable level of fishing. More precise biological and bioeconomic terms define acceptable level as follows. Biological overfishing occurs when fishing mortality has reached a level where the stock biomass has negative marginal growth, as indicated by the red area in the figure. Economic or bioeconomic overfishing additionally considers the cost of fishing when determining acceptable catches. Under this framework, a fishery is considered to be overfished when catches exceed maximum economic yield, where resource rent is at its maximum. Fish are being removed from the fishery so quickly that the profitability of the fishery is suboptimal. A more dynamic definition of economic overfishing also considers the present value of the fishery using a relevant discount rate to maximize the flow of resource rent over all future catches. Harvest control rule. A model proposed in 2010 for predicting acceptable levels of fishing is the harvest control rule, which is a set of tools and protocols with which management has some direct control of harvest rates and strategies in relation to predicting stock status and long-term maximum sustainable yields. Constant catch and constant fishing mortality are two types of simple harvest control rules. Input and output orientations. Fishing capacity can also be defined using an input or output orientation. An input-oriented fishing capacity is defined as the maximum available capital stock in a fishery that is fully utilized at the maximum technical efficiency in a given time period, given resource and market conditions. An output-oriented fishing capacity is defined as the maximum catch a vessel can produce if inputs are fully utilized given the biomass, the fixed inputs, the age structure of the fish stock, and the present stage of technology. Technical efficiency of each vessel of the fleet is assumed necessarily to attain this maximum catch. The degree of capacity utilization results from the comparison of the actual level of output and the capacity output of a vessel or a fleet. Mitigation. With present and forecast world population levels, it is not possible to solve the overfishing issue. However, there are mitigation measures that can save selected fisheries and forestall the collapse of others. In order to meet the problems of overfishing, a precautionary approach and harvest control rule management principles have been introduced in the main fisheries around the world. The Traffic Light Color Convention introduces sets of rules based on predefined critical values, which could be adjusted as more information is gained. The United Nations Convention on the Law of the Sea Treaty deals with aspects of overfishing in Articles 61, 62, and 65. Article 61 requires all coastal states to ensure that the maintenance of living resources in their exclusive economic zones is not endangered by overexploitation. The same article addresses the maintenance or restoration of populations of species above levels at which the reproduction may become seriously threatened. Article 62 provides that coastal states shall promote the objective of optimum utilization of the living resources in the exclusive economic zone without prejudice to Article 61. Article 65 provides generally for the rights of, inter alia, coastal states to prohibit, limit, or regulate the exploitation of marine mammals. According to some observers, overfishing can be viewed as an example of the tragedy of the commons. Appropriate solutions would therefore promote property rights through, for instance, privatization and fish farming. Daniel K. Benjamin, in Fisheries, a classic example of the tragedy of the commons, cites research by Grafton, Squires and Fox to support the idea that privatization can solve the overfishing problem. According to recent research on the British Columbia halibut fishery, where the commons has been at least partly privatized, substantial ecological and economic benefits have resulted. There is less damage to fish stocks, the fishing is safer, and fewer resources are needed to achieve a given harvest. Another possible solution, at least for some areas, is quotas, so fishermen can only legally take a certain amount of fish. A more radical possibility is declaring certain areas of the sea no-go zones, and make fishing there strictly illegal, so the fish in that area have time to recover and repopulate. Controlling consumer behavior and demand is a key in mitigating action. Worldwide, a number of initiatives emerge to provide consumers with information regarding the conservation status of the seafood available to them. The Guide to Good Fish Guides lists a number of these. Government regulation. Many regulatory measures are available for controlling overfishing. These measures include fishing quotas, bag limits, licensing, closed seasons, size limits, and the creation of marine reserves and other marine protected areas. A model of the interaction between fish and fishes showed that when an area is closed to fishers, but there are no catch regulations such as individual transferable quotas, fish catches are temporarily increased but overall fish biomass is reduced, resulting in the opposite outcome from the one desired for fisheries. Thus, a displacement of the fleet from one locality to another will generally have little effect if the same quota is taken. As a result, management measures such as temporary closures or establishing the marine protected area of fishing areas are ineffective when not combined with individual fishing quotas. An inherent problem with quotas is that fish populations vary from year to year. A study has found that fish populations rise dramatically after stormy years due to more nutrients reaching the surface and therefore greater primary production. To fish sustainably, quotas need to be changed each year to account for fish population. Individual transferable quotas are fishery rationalization instruments defined under the Magnuson-Stevens Fishery Conservation and Management Act as limited access permits to harvest quantities of fish. Fisheries scientists decide the optimal amount of fish to be harvested in a certain fishery. The decision considers carrying capacity, regeneration rates, and future values. Under ITQs, members of a fishery are granted rights to a percentage of the total allowable catch that can be harvested each year. These quotas can be fished, bought, sold, or leased, allowing for the least cost vessels to be used. ITQs are used in New Zealand, Australia, Iceland, Canada, and the United States. Only 3 ITQ programs have been implemented in the United States due to a moratorium supported by Ted Stevens. In 2008, a large-scale study of fisheries that used ITQs compared to ones that didn't provided strong evidence that ITQs can help to prevent collapses and restore fisheries that appear to be in decline. China bans fishing in the South China Sea for a period each year. Removal of subsidies. Several scientists have called for an end to subsidies paid to deep-sea fisheries. In international waters beyond the 200 nautical mile exclusive economic zones of coastal countries, many fisheries are unregulated, and fishing fleets plunder the depths with state-of-the-art technology. In a few hours, massive nets weighing up to 15 tons, dragged along the bottom by deep-water trawlers, can destroy deep-sea corals and sponge beds that have taken centuries or millennia to grow. The trawlers can target orange roughy grenadiers, or sharks. These fish are usually long-lived and late-maturing, and the populations take decades, even centuries to recover. Fisheries scientist Daniel Pauly and economist USSIF Rashid Soumaila have examined subsidies paid to bottom trawl fleets around the world. They found that $152 million per year are paid to deep-sea fisheries. Without these subsidies, global deep-sea fisheries would operate at a loss of $50 million a year. A great deal of the subsidies paid to deep-sea trawlers is to subsidize the large amount of fuel required to travel beyond the 200-mile limit and drag-weighted nets. There is surely a better way for governments to spend money than by paying subsidies to a fleet that burns 1.1 billion liters of fuel annually to maintain poultry catches of old-growth fish from highly vulnerable stocks, while destroying the habitat in the process. Poorly. Eliminating global subsidies would render these fleets economically unviable and would relieve tremendous pressure on overfishing and vulnerable deep-sea ecosystems. Soumaila. Minimizing fishing impact. Fishing techniques may be altered to minimize bycatch and reduce impacts on marine habitats. These techniques include using varied gear types depending on target species and habitat type. For example, a net with larger holes will allow undersized fish to avoid capture. A turtle-excluder device allows sea turtles and other megafauna to escape from shrimp trawls. Avoiding fishing in spawning grounds may allow fish stocks to rebuild by giving adults a chance to reproduce. Aquaculture. Aquaculture involves the farming of fish in captivity. This approach effectively privatizes fish stocks and creates incentives for farmers to conserve the stocks. It also reduces environmental impact. However, farming carnivorous fish, such as salmon, does not always reduce pressure on wild fisheries. Since carnivorous farmed fish are usually fed fish meal and fish oil extracted from wild forage fish, aquaculture played a minor role in the harvesting of marine organisms until the 1970s. Growth in aquaculture increased rapidly in 1990s when the rate of wild capture plateaued. Aquaculture now provides approximately half of all harvested aquatic organisms. Aquaculture production rates continue to grow while wild harvest remains steady. Fish farming can enclose the entire breeding cycle of the fish, with fish being bred in captivity. Some fish prove difficult to breed in captivity and can be caught in the wild as juveniles and brought into captivity to increase the weight. With scientific progress, more species are being made to breed in captivity. This was the case with southern bluefin tuna, which were first bred in captivity in 2009. Consumer awareness. Sustainable seafood is a movement that has gained momentum as more people become aware of overfishing and environmentally destructive fishing methods. Sustainable seafood is seafood from either fished or farmed sources that can maintain or increase production in the future without jeopardizing the ecosystems from which it was acquired. In general, slow-growing fish that reproduce late in life, such as orange roughy, are vulnerable to overfishing. Seafood species that grow quickly and breed young, such as anchovies and sardines, are much more resistant to overfishing. Several organizations, including the Marine Stewardship Council and Friend of the Sea, certify seafood fisheries as sustainable. The Marine Stewardship Council has developed an environmental standard for sustainable and well-managed fisheries. Environmentally responsible fisheries management and practices are awarded with the use of its Blue Product Eco-label. Consumers concerned about overfishing and its consequences are increasingly able to choose seafood products that have been independently assessed against the MSC's environmental standard. This enables consumers to play a part in reversing the decline of fish stocks. As of February 2012, over 100 fisheries around the world have been independently assessed and certified as meeting the MSC standard. The Where to Buy page lists the currently available certified seafood. As of February 2012, over 13,000 MSC-labeled products are available in 74 countries around the world. FishNamp Kids is an MSC project to teach school children about marine environmental issues, including overfishing. The Monterey Bay Aquarium Seafood Watch program, although not an official certifying body like the MSC, also provides guidance on the sustainability of certain fish species. Some seafood restaurants have begun to offer more sustainable seafood options. The Seafood Choices Alliance is an organization whose members include chefs that serve sustainable seafood at their establishments. In the U.S., the Sustainable Fisheries Act defines sustainable practices through national standards. Although there is no official certifying body like the MSC, the National Oceanic and Atmospheric Administration has created Fishwatch to help guide concerned consumers to sustainable seafood choices. See also a guide to good fish guides. Awareness in the fishing community. Creating awareness of overfishing and effective measures can be effective in fisheries management. Improving awareness of regulations can improve compliance. Also, creating public awareness of environmental impacts of fishing can lead to fishermen voluntarily engaging in practices such as catch and release.